Good evening, fellow scholars, and I'm going to be talking about our Module 4 exam. Okay, so for number 1, we have a hexagon, a trapezoid, a triangle, and a rhombus. And they want us to use 4 sets of fractions, having the 3 fractions in each set, and let each pattern or block be the base unit for each pattern or fraction. Okay, so for number 1, we're using a hexagon, trapezoid, triangle, and rhombus. Show their relationship using fractions. I will represent the different fractions between all of them. The hexagon, which is shown, the trapezoid, the triangle, and the rhombus. We will first start with the hexagon and how the trapezoid, triangle, and rhombus can all fit into it or form into it. There's shown what the hexagon looks like. Okay, so let me get my pen. Okay, so we have the trapezoid. Okay, if you take one trapezoid, it can be placed inside a hexagon twice by making the fraction 1/2. Okay, shown because that's what a trapezoid looks like. Okay, so for the triangle, if you take one triangle, it can be placed inside a hexagon 6 times, making the fraction 1/6. Okay, because here's one triangle, here's another, here's another, here's another, here's another, here's another. So that'd be 1/6. Okay, for a rhombus, if you take one rhombus, it can be placed inside a hexagon 3 times, making the fraction 1/3. As shown here is the rhombus. 1, 2, and 3. Okay, so whoops. Okay, so for the next one, is it loading? Okay. Okay, so for this part, now we're going to do the same with the trapezoid. We're going to see how many times a triangle, rhombus, and hexagon can fit inside the trapezoid, which is shown right there. Okay, for the triangle, if you take one triangle, it can be placed inside a trapezoid 3 times, making the fraction 1/3, being shown 1, 2, 3 triangles. For a rhombus, if you take one rhombus, it can be placed inside a trapezoid 1 full time with some left over, so it'd be 2/3. If you take one hexagon, it can fit into 2 rhombuses, making the fraction 2/1. As shown, here's a hexagon right there, and then a trapezoid right there. Okay, now we're going to do the same for the triangle, which is right here. Okay, if you take one hexagon, it can be placed inside 6 triangles. Okay, so here's the hexagon, and 6 triangles can be placed inside it, so it'd be 6/1. A trapezoid, if you take one trapezoid, it can be placed inside 3 triangles to make the fraction 3/1. A rhombus, if you take one triangle, it can be placed inside a rhombus 2 times, making it 1/2. For number 3, the rhombus, okay, for a hexagon, if you take one rhombus, it can be placed into 3 times into a hexagon to make the fraction 3/1. Show the 3 different rhombuses. Okay, if you take one rhombus, it can be placed inside a trapezoid once with half the rhombus left with the fraction 3/2. For a triangle, if you take one rhombus, it can be fit into 2 triangles with the fraction 1/2. Okay, so for number 3, we will represent each fraction with the question being, represent each of the following fraction functions with the fraction strip model and a number line. Okay, so the first one is 1/3 plus 1/2. Okay, so we will represent each fraction starting with A, which is 1/2 plus 1/3. We will start by drawing the models for each fraction. We're going to work the problem by cross-multiplying using the butterfly method. We will need the same denominators for both. To do that, we will multiply the 3 times 2, which is the common denominator, 6. Then we'll cross-multiply the original fractions. Okay, so here's the diagram given. We have 1/3, and so we'll draw 1/3, 3 blocks, and 1 being colored, plus 1/2, which is 2 blocks and 1 being covered, equals 5/6. And how we got that is because you have 1/3 and 1/2. To find the common denominator, you take both the numbers on the bottom and multiply them to give them 6. Then we'll cross multiply. So 1 times 2 and 1 times 3. 1 times 2 equals 2, 1 times 3 equals 3. Then you combine them, so it's 2 over 6 plus 3 over 6. Add the top two together, and you get 5 over 6. For 3b, we'll do the exact same thing that we did on the first one. Okay, so you have 1/2 and 3/4. Well, you have to get the common denominator, so you multiply 2 times 4 equals 8. Okay, so then you cross multiply 1 times 4 and 3 times 2. So you get 4 and 6. Then you add them together like we did before, and you put 4 over 8 and 6 over 8. Then you combine them, and you get 6 plus 4 equals 10, so 10 over 8. But that is a improper fraction, so we have to simplify it. So you get 5/4 because both of them divide into 2. 10 divided by 5 equals 2, or 10 divided by 2 equals 5, and 8 divided by 2 equals 4. Well, that is still an improper fraction, so it can be changed to a mixed number. So 1 and 1/4, because 1 times 4 equals 5. 1 times 4 equals 4, plus 1 equals 5. So 5 over 4. Okay, then we show with the diagram, you have 2 blocks, one colored because it's 1/2. Then you have 4 blocks, 3 over 4, so 3 blocks are covered. And then it's shown with 5/4 or 1 and 1/4. Okay, for C, we will subtract, so it's a little bit different. Now we'll subtract instead of add the fractions. We're multiplying the numerator by the other denominator. Make sure they're in the same spot. Okay, so 3 over 4 minus 1 over 3. We multiply 4 times 3 because we have to get the common denominator, which is 12. Okay, so then we cross multiply using the butterfly method. 3 times 3 and 1 times 4. So we get 9 and 4. Okay, so put them over the denominator. 9 over 12 minus 4 minus 12, or 4 over 12. 9 minus 4 is 5, so then we get 5 over 12. Show them with the diagram, 3/4, 1/3, and what it comes out to be, 5 over 12. Okay, for D, we have 3/4 minus 3 over 6. Multiply 4 times 6 to get the common denominator, 24. Cross multiply using the butterfly method. 3 times 6 and 4 times 3, 18 and 12. So then we put it over the fraction, 18, 24, and 12 and 24. Subtract them, you get 6 over 24. But both can go into 6, so you divide. So then you get 6 divided by 6 over 24 divided by 6 equals 1/4. And that will be the final fraction for that. Okay, for number 4, to represent the fraction functions, we will multiply them by a whole number. But to do that, the whole number must be converted into a fraction. Adding a 1 under the whole number, turning it into a fraction, that will make them easier to solve. Okay, for A, they give us 3 times 1/5. Okay, to get that, to make it a whole number, you need to convert it into a fraction, so you'll put 3 over 1. Okay, so you get 3 over 1 times 1 over 5 equals 3/5. Okay, because 3 times 1 equals 3, 1 times 5 equals 5. Shown with the diagram over here. Let me get my highlighter, my spotlight. Okay, so you get 3/5, and to find that diagram, you have 3 circles, and with each of them, it's 1/5 is highlighted. So 1, and then there's 5 areas. To come out to be 3/5, 3 covered, and then there was 5 areas, and 3 of them were covered. Okay, for B, you're stuck with the whole number that you have to make into a fraction. Okay, so 3 times 2, 4. So put it over 1. 3 times 2 is 6, and 1 times 4 is 4. Simplify that, and you'll get 1 over 2/4. Okay, you multiply 1 times 4, which is 4, plus 2 is 6. So simplify that, and you'll get 1 over 1/2. Okay, you'll do the same thing. Since you got 1 over 1/2, or to get 6/4, you'll have 3 diagrams, and each is 2/4, so 2 will be covered out of the 4. And it'll come out to be 6/4, which is right here. 4 is covered, 5, 6 over 4. Okay, you do the exact same thing for C. You have 5 times 5 over 8. Well, that's a whole number. You need to change it to a fraction, so you put it over 1. So 5 over 1 equals 5 over 1 times 5 over 8 equals 25 over 8. Here's the diagram being shown. 3 times 8 equals 24. So plus 1 over 25. So you get 3 and 1/8. 8 goes into 25 and 3 times with a remainder of 1, shown right here. Okay, with the D, you start with the negative sign. With the negative sign, one odd number out of the signs, your answer will be a negative. But if there's an even number of signs in the problem, the answer will be positive. Okay, so this one only has one negative, so we know that it's going to be a negative answer. Okay, so you'll do the exact same thing. You have negative 5 times 5 over 8. Well, you'll put 5 over 8 over 1, and you'll get times 5 over 8. So you'll get negative 25 over 8. To simplify that into a whole number, a correct fraction, you'll get negative 3 over 1/8, because that's the improper fraction right there. Okay, since there was one negative sign, you'll know that the answer comes out to be negative 25, because negative 3 times 8, right there, is negative 24. Negative 24 plus 1 equals 25, which is right there shown. Okay, for 6, with the given ingredients list being used to make 16 brownies, but we have to figure out the ingredients we will need to make 12 brownies. So we're going to have to bring down some of the fractions because you won't need as many ingredients to make 12 as you would 16. So we'll convert all the ingredients and measurements, figuring out the percentages and fractions with the ingredients needed for 12 over 16 brownies. Let's start by simplifying the fractions and then divide both sides by 14. So 12 divided by 16, or 12 over 16 divided by 4 equals 3/4 or 75%. So taking 3/4 or 75% of each fraction, multiply each fraction by 3/4 straight across. Okay, so this side is the original and this side will be our new recipe. Okay, so 1/3 cup of butter, you'll multiply 1/3 by 3/4, so you'll get 3 over 12. 3 over 12 can be subtracted because they can both go into 3, so it'll come out to be 1/4. So for the new recipe, you'll get 1/4 cup of butter. 3 ounces of unsweetened chocolate, 3 over 1 times 3/4 equals 9 over 4. Or to put it into a regular fraction, it'll be 2 over 1/4. So you'll need 2 over 1/4 ounces of unsweetened chocolate. 3/4 cup of sugar, you'll multiply 3/4 times 3/4, so you'll get 9/16. So 9/16 cup of sugar. 1 1/2 teaspoons of vanilla, multiply 1 1/2 teaspoons of vanilla by 3/4. We'll go ahead and put that into a regular fraction, and it's 3 over 2 times 3 over 4, and you get 9 over 8, which can be simplified into 1 1/8. So you need 1 1/8 teaspoons of vanilla. 2 eggs, 2 over 1 times 3/4 equals 6 over 4. Well, let's put that into a simplified fraction, and you get 1 2/4. Or that can be simplified to 1 1/2. So you'll need 1 1/2 of eggs. Okay, for the last, you'll need 2/3 a cup of flour. But 2/3 cup of flour times 3/4 equals 6 over 12, which can be simplified down to 1 over 2. So you'll need 1/2 cup of flour. Okay, that is all I have for my written exam, Module 4. I hope you've enjoyed this. Thank you.